Alright, now let's take a look at solving exponential and log equations. So let's look at solving exponential equations and log equations. So solving exponential and log equations. Alright. So let's take a look at the exponentials first. Now the key here is that we have to take advantage of the one-to-one properties of both of these actually, right? So let's take a look at the one-to-one property. So one-to-one property of exponentials. Oops. Here's what I mean by that. Right? If I have a base to a certain power x equal to a base to a certain power y, same base, right? Base is a in this case. The conclusion then, since these are one-to-one functions, is that x must be equal to y. Okay, so in other words, we can set the exponents equal to each other in that situation. All right, and likewise for logarithms too. So one-to-one, we'll get to that in a moment, but one-to-one property of logs is the same thing. All right. Again, if log base a of x is equal to log base a of y, then we say that x is equal to y. All right. So similar concepts, but let's talk about the exponentials first. So if I give you this equation, let's say I have 2 to the let's say 2x minus 5 is equal to 2 to the, let's say 3x plus 7. Let's say we're asked to solve this equation. All right, solve for x. Well then, since exponential functions are one-to-one, then we simply, and the base is the same, then this implies that 2x minus 5, this exponent is equal to 3x plus 7, that exponent. So this equation boils down to solving 2x minus 5 equal to 3x minus 7, which we can easily solve by getting x on one side and numbers on the other side. For example, subtract 2x on both sides. Let me combine steps if you don't mind here since I'm running out of space. Let me subtract 7 on both sides to get the numbers on the left side. So this is just x right here, and this will be negative 12 equal to x, or x is equal to negative 12 is my solution, as you can see. So not hard at all. Right? Let's try another one. Let's take a look at something like 7 to the 4x minus 9 equal to 7 to the 6x plus 1. Again, just same base, right? So therefore these exponents must be the same. So we're just solving 4x minus 9 equal to 6x plus 1. No big deal, as you can see. Again, we'll get the x's on the right by subtracting the 4x. Easy equation to solve. And we'll get numbers on the left by subtracting the 1. So we get negative 10 is equal to what? 2x. Dividing both sides by 2, we get x to be what? Negative 5 as our solution. Alright? So as you can see, this is not difficult at all. We just simply set the exponents equal to each other if the base is the same. Now, what if the base is different? Let me go ahead and give you a different problem. I'm just going to try this one. Let me go and clear out the screen. All right, let me go and clear out the screen. Let me go and try. Let you try this one. What about something like? Let's try something like. How about 4 to the 3x plus 2 equal to 32 to the 5x minus 2. Take a look at this one. Now the base is not the same, so we cannot simply set these equal to each other, right? But let's observe that we can get both of these bases to be the same because 4 and 32 are powers of what? Of 2. Because isn't 4 equal to 2 squared? Isn't 32 equal to 2 to the 5th? Can we see that? So we can rewrite these with the same base as it turns out, right? Doesn't always happen, but in this case we can do that, right? So let's replace the 4 with 2 squared. In other words, let's rewrite the left-hand side as 2 squared. Got to put a parentheses there because you're taking that. That's basically 4, right? We're taking that to the 3x plus 2. So that'd be in parentheses there. So power to that power, right? All right, so what's 32 again? 2 to the 5th. So parentheses 2 to the 5th to the 5x minus 2. All right. Then what do we do when we take power to another power? We multiply the powers, right? Isn't that 2 to the, distribute the 2 here, right? 2 times 3x is going to be what? 6x. 2 times 2 is going to be what? 4. Equal to 5 times 5, 25x. 2 to the 25x. And 5 and negative 2, negative 10. Can we see that? So multiply the powers. When we take the power to another power, we saw this rule earlier. But anyways, now we have the same base. Clearly, we can now set the equations, see the equation, or set the powers, the exponents equal to each other. So 25x minus 10. So now we can do the x on one side and numbers on the other side. Just standard equation to solve. No big deal at all. So we're going to get, let's see, 4 equal to, well, actually, let me combine steps here if you don't mind, since it's not a hard problem, a hard equation to solve. Let me add 10 to both sides to get rid of that. So this will be, what, 14 here, right? So apologize here. 4 and 10 is 14, equal to what? 19x. So x is going to be 14 19ths, dividing both sides by 19. All right, so we get this a fractional answer, obviously, for x for this equation here. But again, get them to be the same base, if you will. Let's try another one, see if we can do that. Let's take a look at what about let's see, what about 25 to the x plus 2 is equal to, let's say, 125 to the 2x minus 1. Let's go and try that one. All right. Again, the bases are different, but can we get them to be the same? Yes, we can, because that's basically what, 5 squared here, 25. So I can say that's 5 squared to the x plus 2. And what's 125? Isn't that 5 cubed? Right, 125. So 5 cubed to the 2x minus 1. All right. So hopefully we can see that without too much difficulty there. But anyways, let's go ahead and solve it as we did here. So power to power, you multiply power, right? Distribute the 2. So 5 to the 2x plus 4. All right. And equal to 5 to the what? 6x, right? 6x minus what? Minus 3. Okay. So we have that situation there. So now we can get the equation now. Same base, so 1-to-1 property. So 2x plus 4 is equal to 6x minus 3. All right, no big deal. Again, let's subtract the x on one side and numbers on the other side. Add 3 to both sides there. Takes care of that. So 7 is equal to what? 4x. So x will be what? 7/4. Dividing both sides by 4 for our solution. All right. So again, the key is what? Get them to the same base. But sometimes you can't always do that. Here's what I mean by that. Let me give you a problem with that. Let me go clear up the screen. Let's say we have an equation such as this one. Let's say we have something like 2 to the x is equal to let's say 20. Let's say 24, for example, right? 2 to the x equal to 24, right? Look at the simple equation. There's no way I can write 24 as a power of 2, right? Because 2 to what power is 24? We don't know, right? It's going to be a decimal answer. But there's another technique that we can use for this, and that technique is taking the logarithm of both sides. You can either take the logarithm or the natural logarithm. So this is a calculator problem right here. Right? Since we cannot write 24 as power of 2, so we need to use our calculator to solve this. But before we do that, we have to somehow get this x back down here to solve for x. Right? How do you get x back down to solve for it? Well, you have to take the log or the natural log of both sides. Use that power rule property to solve for x. Here's what I mean by that. So if 2 to the x is equal to 24, let me take the log, the common logarithm, base 10, right? So take the log of both sides. In other words, I'm going to write this equation as log of 2 to the x equal to log of 24. And what's the base again? Base is 10. Implied to be 10 if it's not written, right? That's the common logarithm, the log button on your calculator. All right? So anyways, with the power rule, then once I take the log of both sides, the x can now come down to the front. So this will be x log 2 equal to log 24. And now, as you might suspect, we can now divide out the log 2 to solve for x. So I can punch that into the calculator. Typically, we'll try to round to 3 or 4 decimal places. All right, so let me punch into the calculator. 24 log divided by 2 log on my calculator is roughly 4.585. So roughly 4.585. Rounding to 3 decimal places in this case. All right. So, but on homework, just round to the decimal place the text desires for you to do that. All right. Let's try another one. Let's try another one here. So, let's see here. Hold on just a second. Let's see my sketch packing work well again. All right, there it is. All right, we're back. All right, sorry about that. Okay, let me go ahead and try this problem. What about let's take 2 to the x minus 3 equal to, let's say how about 397. 397. All right. So pretty big number, but no big deal. Again, theme is what? Take the log of both sides, or we can also take the natural log, because we have this ln button on our calculator, right? Let me use ln. Let's take the ln of both sides. Natural log 2 to the x minus 3, ln of 397. All right. Again, power rule says what? The x minus 3, the power comes down to the front. So this will be x minus 3. Got to have it in parentheses because the entire thing comes down. ln 2 equal to ln 397. All right. Now this is a little bit more complicated to solve, but not a big deal. Let's divide both sides by natural log of 2. By ln 2, takes care of that. So you have x minus 3 is equal to this number, whatever it is. We can punch it into the calculator, right? That's just a decimal number. Right? ln 397 divided by ln 2. And now just add 3 to both sides to finish off solving for x. So x is going to be what, approximately? Why don't you punch that and punch this? This is the actual solution, but let's punch it into the calculator, round it off again to 3 or 4 decimal places. Right, so I'll use ln this time. So see, 397 natural log divided by 2 natural log is going to be 8.63, but I'm going to add 3 to that. So we're going to get 11.633. So roughly on the calculator here, I get 11.633, rounding to 3 decimal places here. All right, so not a big issue here. So we simply have to just punch into the calculator carefully to get the solution here. But the theme here is we can take the log of both sides to solve these equations. If we cannot write both sides to be the same base. All right, in this case we can't. So use this either the log of both sides. We have this log button, common logarithm, or the natural log of both sides. We have the natural log button on our calculators. All right, let's go ahead and do one, squeeze one in down here if I can fit it in. We'll try our best here. What about something like this? Or how about let's look at how about 5 to the x plus 2. All right, equal to, let's say let's see here. So 5 to the x plus 2 equal to, let's make it, let's see, how about big number here? How about, let's see, 2,430, 2430, let's say. Okay, so pretty big number. But again, we'll take the log of both sides. I'll go back to logarithm here. So we'll go log of 5 to the x plus 2 equal to log, again, base is 10, right, of 2430. No big deal. We can punch on the calculator. Again, the x plus 2 will come out to the front. So we have x plus 2 times log 5 equal to log of 2430. Right, divide both sides by log 5, as we did in the earlier problem. Similar steps, right? Takes care of that. So we have x plus 2 equal to, again, this number we can certainly punch in the calculator, but I like to punch it all in at the end. So I'm just going to write it as it is here. Right? Subtract 2 on both sides to finish the problem out. So therefore, x is going to be approximately, let me punch this into the calculator again, using the common log button here, the log button that is, right? So we get 2430 log divided by, 5 log all right, which is 4.844 roughly minus 2. So we get roughly for x 2.84. Well, I'll go to 4 decimal places. 2.8437. So 2.8437. Now again, just follow the text in terms of how many decimals to round to when you do the homework on this. All right. So usually 3 or 4 decimal places is sufficient for these kinds of problems. All right. Anyways, practice this concept of taking the log of both sides when you're solving this exponential equation. Let's turn our attention to log equations now. So we know how to solve exponential equations by, again, both bases are the same. If we can't do that, then we go to taking the log of both sides or the natural log of both sides. All right, let's try some log equations. Well, the key to solving log equations, let's start real simple. Let's start with something like log base 6 of x minus 2 is equal to, let's make it equal to 1 for simplicity's sake, all right? The key to solving these log equations is simply converting them, as you may suspect, to exponential equations. So when you say convert to exponential equation, all right? How do we do that again? This is the not the x, but the base. That's the exponent. Right? So this is 6 to the first power is equal to whatever's inside the log, x minus 2. So pretty easy, as you can see, right? Not hard at all. So 6 to the first is 6, x minus 2. So let's add 2 to both sides to solve it. So x is equal to 8 in that situation. Here, let's try another one. Let's take the log. Let's solve log base 9, let's say. Log base 9 of 2x plus 7, make it equal to, let's make it equal to 2 here. Alright, so again, convert this to an exponential. So here's the base, there's the exponent. So what, 9 squared, can we see that? Base to the exponent is equal to whatever's inside the log, 2x plus 7. Right? What's 9 squared? 81 equal to 2x plus 7. So again, easy equation to solve. Subtract the 7 to both sides. So we're going to get what? 74 equal to 2x. Or x is equal to what? 37. Dividing both sides by 2 to solve it. Now you can certainly plug it back in to get the to check your answer. Let's plug 37 back in. What's 2 times 37? 74 plus 7, 81. What's log base 9 of 81? In other words, what exponent must we take 9 to get 81? Well, 2, obviously. So it's going to check out. All right? Our basically 9 squared matches the 81 number you get when you plug in the 37 for x inside. All right? So converting the log equations to exponentials, we can certainly solve that. But what about the one-to-one property of logs we talked about earlier here? Let's go ahead and try some of those problems here. Well, so let me go and clear out the screen. Let's try some with where we have to use the one-to-one log property here. Let's go and try this one. We'll go ahead and clear out the screen. Let's take a look at this problem here. Let's solve this equation for x. All right? So solve this log equation. What about log base 3x plus log base 3? Let's see, base 3 of x minus 1 is equal to log base 3 of, so let's make the right hand side log base 3 of 6, let's say. Alright? So how do we solve this equation, for example, then? Well, I need to find a way to put these two logs together, but again, we had a property earlier where the product rule is going to apply, where if I'm adding two logs, I can put it together by multiplying those quantities inside. In other words, I can write the left-hand side as log base 3 of x times x minus 1, if you recall, right? And that's equal to log base 3 of 6. So this is log base 3 of what? X squared minus x, equal to log base 3 of 6. Alright? Again, one-to-one property of logs is what? Same base, right? We can set the two quantities equal to each other, right? That I wrote down from the beginning. So in other words, this equation boils down to x squared minus x equal to what? 6. So we're solving this simple quadratic equation here, if you will. Just subtract 6 on both sides to solve this by factoring, for example. X squared minus x minus 6 is equal to 0. So we can certainly factor it as what? X minus 3 times x plus 2, right? Two numbers that multiply negative 6 out to negative 1. These two numbers we've seen in the past. So x will be what? Positive 3, if I set them to 0, and negative 2. Can we see that? But go back to the original log equation. Go back to the original log equation because let's take a look at this negative 2 here, right? Remember, you can't take log of a negative number. So if I plug in negative 2 for x, this will be undefined. This will be an error in our calculator, right? So therefore, you can't take log of a negative number, so negative 2 in this case should be eliminated. Now, again, just because it's negative doesn't mean it should be eliminated, but when we plug it back in, if the result inside is a negative number, then we cannot plug that in, right? So, for example, let's say x was equal to 1, a positive number. Well, you can't even plug that in because 1 minus 1 is 0. You can't take log of 0, right? So, but again, my point is what? Check these answers carefully with the original equation to make sure we're not taking log of a negative number. In this case, negative 2 will cause that to happen. So therefore, we need to eliminate negative 2. So the answer is simply going to be just the 3, if you will. Okay, so we have to be careful on these types of problems. Let's go and try another one. I'm going to clear out the screen. What about, let's try ln of 4x minus, parenthesis there, sorry about that, minus ln of x plus 10, all right, is equal to the natural log of 2, ln 2. All right. Now, how do I put these two logs there? Well, we have the quotient rule, right, where we, if we're subtracting the two logs, we can what? Divide these two quantities, right? So this is basically ln of 4x over x plus 10 equal to ln of 2. Again, one-to-one property of logs, we can set these things equal to each other. So the equation we're solving is going to be what? 4x over x plus 10 equal to what? 2 in this case. Can we see that? So nice easy equation to solve. Let's get rid of the x plus 10 by timesing it to both sides. We solved this equation in the past. No big deal. Takes care of that. So 4x is equal to what? 2x plus 20. All right. And then just bring 2x over. Again, x on one side, numbers on the other. So 2x is equal to 20, or x is equal to what? 10 if I divide both sides by 2. All right. So let's check our answer. Make sure we're not taking log of a negative number. 10 is okay here. 10 is not going to cause that to be negative, so we're good. All right. So 10 is the solution we're looking for in this case, and we're using the quotient rule in this example versus the product rule in the previous example. All right. So so you can get a better feel for these types of problems here, if you will. Well, actually, let's just do one more real quickly for you, and before I give you some problems I want you to solve and post into Blackboard, for example. Let's go and try one more here. What about log, let's do log, oops, sorry about that, log base 7 of 5x equal to log base 7 of 3, let me squeeze that in here, plus, I'm running out of space here, let me go log base 7 of 2x plus 1. Alright, 2x plus 1. Sorry to write so close to the edge here. But again, log base 7 of 5x equal to log base 7 of 3 plus, that's a plus right there, log base 7 of 2x plus 1. But again, plus means what? We can multiply these things together, right? Multiplication, product rule. So this is going to be log base 7 of 5x equal to log base 7 of 3 times 2x plus 1. Can we see that? All right, using the product rule. So this is log base 7 of 5x equal to what? Log base 7 of 6x plus 3. Can we see that? If I distribute the 3 there, all right? Again, one-to-one property says we can set 5x equal to 6x plus 3. Bottom line. All right, let's go and subtract the 6x on both sides to get the x's on the left. So we get negative x is equal to 3. X will be what? If you divide by negative 1, negative 3. All right, negative 3. Now, take a look at the answer negative 3. Does it work with the original equation? Well, no, it does not, because look, 5 times negative 3 is what? Negative 15. So this will cause us to take the log of a negative number if I plug in negative 3 for x. Can we see that? So this is not a valid answer, so not valid. In fact, for this particular equation, there's simply no solution. Okay, no solution is the answer we're looking for here. All right? So sometimes you may not get a solution for these types of equations, bottom line. But use the product rule for this. If you're adding 2 logs, use the quotient rule if you're subtracting 2 logs. Bottom line there. All right. I'm going to clear out the screen, give you some problems to try and post into Blackboard here. So let me go and clear out the screen. Right, number 1, I want you to solve the following equations. Let's go and solve these equations. 9 to the x minus 1 is equal to 27 to the x plus 4. Okay, so get a common base. All right. So hopefully we can do that here. Think about that a little bit. Number 2, let's go and solve the log equation. Log base 7 of 2x plus 5 equal to 2. Okay, no big deal. Convert the log to what? An exponential in that case, right? And last but not least, let's go ahead and take a look at this equation here. Ln of x plus ln of 2x plus 1 equal to the ln of 6. All right, so think product rule again, right, for adding 2 logs to put together. So solve these 3 problems and post the solutions into Blackboard, and we'll go over it in class. All right, until next time then. Take care.